Alright, so this is Gabriel's form. It's defined as f of x is equal to 1 over x on the interval from 1 inclusive to infinity, non-inclusive. And you can imagine if you draw these axes, y, x. So you can imagine if you revolve it around the x-axis right here, it'll, if you drew a mirror thing, it'll make a form-like thing, and it has some cool properties about it. So if we want to find the volume of it, volume, you can find that by doing the interval of pi, integral from a to b of f of x squared dx. So f of x is just going to be 1 over x. A is going to be 1, but b, we can't put an infinity in there, or else it will be improper, so we're going to do a limit instead. As b goes to infinity, so we'll do pi limit as b approaches infinity with integral from 1 to b, 1 is a, and then of 1 over x, that's f of x squared dx. Okay, 1 over x squared is 1 over x squared, so equal to pi limit b approaches infinity, integral from 1 to b 1 divided by x squared dx. Okay, so integral of 1 over x squared is negative 1 over x, so we'll do that. What was it? Pi times negative 1 divided by x, the bounds from 1 to b. Can you see that in the video? Yeah, barely. I should write bigger, but I don't like the negative 1 being there, so I'm just going to flip it down to get rid of the negative. I'm going to do is equal to pi times 1, I'll forgot the limit, sorry. It's equal to pi times the limit b approaches infinity, negative 1 divided by x from 1 to b. Then I'm going to switch the negative with the bounds to pi times limit b approaches infinity of 1 divided by x from b to 1, since I switched it. I'll plug in 1 and the b in, so it's equal to pi limit b approaches infinity of 1 divided by 1 is 1 minus 1 over b. So as b goes to infinity for 1 over b, that's just going to go to 0. So you can see that pi times 1 is equal to pi. Should definitely write a bit bigger. But if you do the surface area, it's going to be so this is like, this surface goes to infinity, but it has finite volume, which is pretty cool. If we do the surface area, formula would be 2 pi integral from a to b of y square root of 1 plus the first derivative of y, so dy dx squared dx. And this actually comes from, this square comes from if you want to take the arc length of it, but we're revolving it around the x-axis, so it's going to be a bit different. So let's start plugging things in. Again, we don't want an infinity in there, and also be improper, so we're going to do the whole limit thing again. So equal to 2 pi limit b approaches infinity. From 1 to b of y is 1 over x, or should have done f of x, just keep it consistent. Times square root 1 plus, okay, first derivative of 1 over x is negative 1 over x squared, so 1 over x squared, all of that squared, dx. I'm going to square that 1 over x squared to make it 1 over x to the fourth. 2 pi limit b approaches infinity. And then go from 1 to b, probably in the way of that. 1 divided by x squared of 1 plus 1 divided by x to the fourth dx. So I don't know how to integrate that, but we can compare it to a similar integral. If we compare it to 2 pi limit as b approaches infinity of integral from 1 to b 1 over x dx. I can do that. I'll figure it out and I'll explain why I'm doing that and why that compares to this integral right here. So integral of 1 over x is natural log of x, so put that in. Let's do over here. Equals 2 pi limit b approaches infinity of natural log of x on the bounds from 1 to b. Okay, I'll plug those in. 2 pi limit approaches infinity of L natural log of b minus natural log of 1. Put some parentheses in there. Natural log of 1 is 0. So equal to 2 pi times limit b approaches infinity of natural log of b. Okay, as b approaches infinity for natural log of b, that just goes to infinity, so that integral will diverge. Diverges. Okay, so if you compare it to this one right here, it's basically the same thing, but you have the square root thing. And in the square root thing, you have 1 plus 1 over x to the fourth. So this term will actually always be greater than or equal to 1 because no matter what x is, this term, the 1 over x to the fourth, is going to be greater than or equal to 0. Add that to 1 is greater than or equal to 1, take square root, same thing. So this thing is this factor right here is always going to be greater than or equal to 1. So you can imagine multiplying a diverging series by something bigger, and that will never converge. So the surface area integral diverges. So this form has finite volume but infinite surface area, which I think is pretty cool. I gotta write that bigger. Yeah, I'll do that for the next one. You can barely read that.